To be here. So I'm Shawn McCool. I've been involved in Laravel since Laravel 2, where it was basically changing every single day. And when we started the IRC channel, we had about 10 people who were interested. And I guess 3 years ago, when I left to let the younger generation teach everybody how to use the framework, we had somewhere over 450. So it's grown a lot. I have been developing for 29 years, 20 years professionally, and over that time I've shipped about 40 web apps of various sizes, sometimes up to 10 a year. And I have experienced everything from being a front-end developer to being a back-end developer, project management, entrepreneur, basically the whole gamut of things. In addition, I've worked on very small projects and very large projects with very big teams. So I'm coming at this from an angle where Laravel is often used in web agencies or product companies to do backends, etc. And there is a definite idiom in Laravel, an idea of how the application comes together. And there are some pain points that aren't often discussed, and so I wanted to have this talk opportunity to discuss some of those. The first thing I think that we can all agree on is refactoring is good. So as the application goes through its lifespan, we have to be able to change the application. So you may have the experience that I have experienced countless times where I work really hard, focus on getting the job done, getting a new feature added, getting something changed. I ship the product, I hand it over to the client, and then it comes back and there's problems, there's errors that I didn't see, I didn't perceive. And I feel like the last 10 years have been a huge journey for me just to try to identify the ways in which I could keep this from happening and reduce the amount of problems that I was exploring. I need to start by kind of exploring the idea of a model. Is anybody familiar with the idea of like a model, like a conceptual model, data model, that kind of thing? So I'm just going to run this real quick then. So a conceptual model is just the way you understand something. It's the ideas that are connected in your head, and you and another person are going to have different models for the same general ideas. Now, you have things like, of course, modeled cars and modeled trains, and those are reductions of the reality. So a model car isn't going to have all the exact things that a true real car has. It's reduced down to a useful form, a form specifically designed for a use. Often, for example, play. So it just has to look like a car and maybe roll across the floor, and that's good enough to be useful. So the whole idea of a model, and for example, a conceptual model, is you can't understand all of reality. It's too complicated for our minds. So we have these reduced, simplified forms, and that's what we operate with. And the whole point is just to get some use out of them. So when it comes to the actual framework systems, in the model view controller, for example, we often have these kind of models, which are very specifically ORM. And the idea here is, of course, that you have a database, and these represent records within those databases, but they're a behavioral layer on top. So we can do things like formatting, relationships, interactions on top of that. And so this is what I would consider more of a data model approach. The mathematician George E.P. Box said that essentially all models are wrong, but some are useful. And the key here is that a model cannot be entirely true. It's necessarily a reduction. Therefore, we have to treat them with some skepticism, because there are many ways to come to a useful outcome, very different models. So we have to be able to balance models, and often as developers we come into a situation already knowing how we're going to implement it and not considering alternate possible models. Now, a short bit of history regarding data modeling. What we generate is usually business information systems. So we're not making, 3D video games or, I don't know what, microcontroller code. So we're working in a specific kind of field. And before 1970, when developers were building these systems, they didn't have what we use now as the relational model. They had this hierarchical model. So if I wanted to get a list of tasks, I would have to go into the department I wanted, then query into the project, and then query into the tasks. And then if I wanted to learn more about the employees, I'd have to go back up and query in, and then aggregate these things in memory, etc. And it turns out that this is an extremely expensive model. As the data store grows in size, it becomes very inefficient. So in 1970, IBM created this relational algebra that was a communication of how a database system could work. And it's basically like the hierarchical model, but we just sever these ties. Now, instead of having this tree structure, starting from the top, draining down, we have access to any point. So I can go to a task, and I can interrelate these any way I want. Tasks to employees, projects to clock time, etc. And just go from one to another. And this actually affects the way that this model itself affects the way we develop their web applications. As you can see here, we see those relationships communicated within Eloquent's relationship system: has one, belongs to, has many, etc. Now, data modeling in Laravel uses a very specific approach. It's an approach that allows you to get up and running quickly, and it has a very specific paradigm. So one aspect of learning Laravel quickly is just to try to adopt the way of thinking as quickly as possible. So Eloquent, it's an ORM, which means every database record just maps to the object, and it's specifically active record, which means that each object itself understands how to interact with the database. And in the active record implementations, you'll find that, for example, in Laravel, there's an attributes array, and things are stored into that array. And then Laravel uses some magic methods so that you can access those attributes. There are other ways to do that, but this is the way that Laravel is developed. Of course, with the relational model, you can use foreign keys and refer to other records and other tables, and Laravel has this built in. But Laravel also has this direct attribute access. So when you have a model and you can just call an attribute on it, you're directly calling that database field. Just to kind of put this into perspective, there's some other data access models you might be familiar with. Table gateway, where instead of each object representing a record, each object represents the entire table, and usually the records are stored as a very basic data structure. A key value store, where you have a key and you look up data that's the value, but the value is generally opaque. You can't see it. It's just, here's the key, give me the value. And then document databases are an evolution of the key value store, where you can actually have some schema into the value and query into the schema. What I would like to kind of impress, if you're not familiar already, is just how many ways there are to think about how to store and access data. And CodeIgniter, Laravel, Cake, even with Symfony and Doctrine, these all use a very similar idea about how to interact with your core data, but there are very many models available. So one great value of Eloquent is that it takes very little effort to get something running, and this is its core strength, really, I think. We just run a migration, the relation is built, and then we have a class that's like minimum 2 lines if you use conventions, and then you're directly able to interact with that table, and that's pretty special. You can easily access the related data, and this is a theme for me, and it's going to keep coming back. But Eloquent also has a tremendous amount of quality of life features, soft deletes, things like this, that once you learn how to use them, you can use them to great effect. Okay, so this is not about other data access models. This is actually about the negatives of Eloquent, because, of course, as with anything technical, there are trade-offs. If you use an ORM, then you have something called impedance mismatch, and that's what happens whenever you have 2 paradigms that clash. So in the object-oriented model, you have encapsulation, for example. The idea is that whatever's happening inside the object is kept completely opaque from anything outside, so you can change that as much as you'd like, and you don't have to deal with external fragility. But the relational database model does not have this feature. So it's possible to violate your object model by directly accessing the database. This can lead to system instability, unexpected effects. In addition, the active record model leaks your database schema. So what does that mean? One way we can leak our database schema is by having our fields directly accessed off of an object. So here we have isAdmin, and that's a field in my database. So everywhere that I'm calling it a field on an active record model, I'm actually exposing my database schema. In addition, each model is by design representative of a table. Now, it is absolutely possible to have multiple models use the same table, but represent different parts of a process, etc. But generally speaking, if you see something called invoice or member, there's probably an invoices table or a members table, and by virtue of that, our database schema is again leaking up into the application. And finally, relationships. In this case, user is probably a table, is probably from a table users, phone, maybe phone numbers, and then the actual number is probably a field literally called number in that table. So these are all ways in which the database model, the data model, bleeds up into the entire rest of the application. Yep, so here's the database. It comes up into the Eloquent model by design. And then in our controllers, we do queries, we interact with that data. In our templates, we'll often have relationship usage. For example, if I have a form, maybe I have a controller method for displaying a field or a thread in the form. And so I just pass it in a thread model. And in the template, I can do thread author name, thread author profile picture, etc. And then you can see how this even goes up into JavaScript. The way you design the database directly impacts the rest of the entire application. So there's something really connected there, and I feel like that means it requires extra attention. So this is just a short warning. The way I code is not necessarily PSR standard, etc. I've worked in 12-something languages over my career, and I have my own style. So if you don't like it, I'll try to get the talk over in time, and we can move on. But just keep in mind that there's some maybe weird stuff coming. I want to talk a little bit about knowledge, because this idea of the data model leaking into the application is really, it's about what knows about what. So in this case, we have a class that uses a trait. And the class has a dependency on that trait, because if this trait does not exist, the class simply will not compile. It won't run. However, if the class doesn't exist, the trait is fine. The dependency is a one-way direction. And with basic UML, you can just say, hey, I have a class. I point at the other thing, the dependency, and the thing that I'm pointing at is the thing that I can see. So since my class knows about my trait, it's now vulnerable to any changes in my trait that might occur. Similarly, we have function dependency. If I return a response, if anything about that response function changes, like the function signature, then there's a chance that I'm breaking anything that knows about the response function. And whenever we create an Eloquent model, of course, we depend upon the model class. And if that, of course, changes, and this is why when you have to upgrade, of course, you might have to change some of your implementation, because your implementation is dependent upon another system. And if that system changes, then we can become impacted. So what we end up having is a lot of coupling. In this example, if the database field name changes, then this whole thing breaks. It stops functioning. If the authors table changes or something along those lines, then this breaks. And it just every part of this is exposing vulnerabilities. That's something that's okay. We have to make that decision. We have to make the decision of how often we expose ourselves to something failing. Now, that's fine if you have a simple, small model, but has anyone here worked on an application with over 50, 60 models? All right, So quite a few people, so pretty large applications. Things start to get out of hand eventually. So what happens when you have a template and you pass in this model over here, but through the template, maybe nested partials or something, you end up with accessing data over there. Now we end up in a situation where if we go to refactor, we try to clean something up, we try to do a better job, and we end up breaking everything. And because anything that's in a line connected is vulnerable to those changes. This is a big problem for me. So over the past couple of years, I've been taking a few philosophical concepts basically and taking them to extreme, see what I can come up with, and it's really changed the way I develop software, especially complicated systems. That's my focus right now. Reactive distributed large-scale systems has been my focus for a couple of years. So how do we refactor this? What do you do? Like you say, okay, I have this idea about how everything fits together, but if you go change it, you're going to have to change the database schema, migrate all that data into a new schema, change all the objects, all the relations, change every single view that might have anything to do with one of these relations. It becomes so overwhelming that I don't even think that when we're interfacing with such a system, we even really consider it a true option. What I believe is more realistic is that we think, what is the smallest change that's reasonable that I can do to deliver the feature? And then that's what happens. So I feel like we have this shape that we design the system in, and then we're just bolting stuff onto it, and it makes the fundamental shape of the system completely impossible to modify. Now, I have a couple small strategies to improve this situation, and one is just to reduce the amount of leakage so that the data model isn't falling through the entire application. And so this right here to me is the perfect amount of coupling to the database. Eloquent is here to couple to the database. It's this exact point, and it does a great job of it. But after that, once it gets to the controller or once it gets to something else, it's just completely spreads, and it's very difficult to control, requires a tremendous amount of discipline. And if you're working in a large team, I think discipline is very difficult to enforce. So this is my user table. It's just an example. So I have a table of users and some silly fields that don't mean anything. But what I want to do is I want to talk about how to isolate that data model to the Eloquent model. Now, this code here, it's very simple, but it just exposes that worst fear field from the database directly to the view or whatever. And so, of course, if I change that worst fear field, everything's going to break that could possibly touch it. I can change that by implementing it in this way, where I create a method that accesses that attribute. Then, if I change the worst fear field into, for example, fear, the rest of the entire application is dependent upon that worst fear method. It's dependent upon the method, not the attribute. So while this seems somewhat silly to look at this and say, okay, it's just a method with the same exact name as the attribute. What it is it's an isolation layer. It's a layer that allows us to fix things at a single point, change things at a single point, and have it propagate through the system automatically because we're not exposing that actual field. Now, this is another strategy, and I think this is a little bit more compelling, honestly. So instead of like this large interconnected data model, what if we thought about it a little differently? What if we designed features and we isolated features, something along the lines of what you might do in a project management system? So your company says, we want to be able to create this functionality, and it has like a 2-week scope or something like this. So we designed this feature. What if we created these conceptually strong boundaries between these features? So we have feature over here and feature over there, but in between them is this boundary that we just don't cross. We don't interrelate these models. They don't have knowledge of each other. If that's the case, like philosophically, then we should be able to modify one feature. So this is what it might look like. You just have a bunch of interconnected models. You still can keep the way that the data schema is leaking through the direct attribute access. We can do all of that, but by keeping the models as these smaller, isolated, bounded models, we make it so that if we're refactoring or changing one, it doesn't affect the other. So we can modify this one, we can change it, but I think that the obvious question is, well, don't you need that data in other parts of the application? How do you communicate over a firm boundary without sharing knowledge over that boundary? Now, in a way, this is the idea of object-oriented encapsulation, just taken to a different scope, right? So we're taking it out of the object scope into a larger scope, which could be a feature, it could be whatever you might define, because this is really about understanding the trade-offs that we're making when we share data all around the application. So I think Laravel event implementation is really nice. Does anybody here use the event implementation? Yeah, so quite a few. I think it's really important. I don't think it gets enough attention entirely, to be honest. I think the idea is here you have an event that exists outside of another scope, and then you have listeners that just observe that the event occurs and have some kind of reaction. The important thing here is, and this arrow isn't probably thick enough to see very well, but these listeners are pointing in at the event. They know about the event. The event doesn't know about the listeners. So the critical value here is that the event itself becomes a sort of protocol that is able to cross boundaries and be its own isolation layer. If I need to change something, then I can change the event, and as so long as the listeners get the same interface from the event back, then nothing else in the entire application has to change. I can put this into a little bit more practical terms, but the idea of using events like this, I just want to really quick discriminate between domain events and technical events. If you have an event that's related to the actual purpose of your application, like a member was registered or something like that, that would be a domain event. And technical events are like model saved, model updated, that kind of stuff that you might connect into if you're making some kind of higher order system. But this is a kind of a practical example. So when somebody registers for my system and I have a member registered, then I just could have a listener that says, send them a welcome email. I don't have to have in my registration process, registration, send them an email, update their system, whatever. I don't have to do anything like that. I can just say member registered and then have all these different listeners respond and do the work that I need to be done. And these listeners can be queued up. They can be run entirely sequentially. So there's different, of course, trade-offs there. And this is a really powerful system. And I want to talk about how to cross over boundaries with events. And to do that, I have built an application. It's a very simple application. And at the end of the last slide has a link to my GitHub. It's just github.com/Shawn McCool, but as a link to the application, you can interact with it and see all the source code. It's very basic, but the idea is we are conference organizers. It's a domain I know well, so it's an easy example for me. And we want to implement really 3 features, which is we want speakers who are potential speakers who have something that they want to say. We want them to be able to submit their ideas to us, and then our organizers will go ahead and be able to approve those ideas. We want you to come, and we want you to give that talk, and then finally, the organizers are going to be able to create a schedule. And these are just simple features, but I want to develop them in isolation from one another and show how we can communicate across those boundaries. Of course, user authentication is a thing. So what is user authentication really? If I can identify that you are you, then that's it. So typically we use email and password, that's obvious. Biometric scans, 2-factor authentication. There's a lot of different types of ways to authenticate a user. But those are implementation details, right? So our implementation here is basically just, we have a user authentication database table and then the password resets table. This is the same setup that comes stock with Laravel, except for instead of calling it users, I call it user authentication because I'm not using that model to represent a user. I'm using it to represent an identity token, a way to validate their identity. And then, let's see here, just simple stuff. There's no name here. This is just the email password. That's all I'm trying to show with that. The password reset stuff, completely stock, nothing different there. So simple migration. We have an email and password in the user authentication table, and then a password resets table. This is my actual user authentication model. I just call it user authentication table, and then I have a registration method. And this method takes the email and password because I choose to implement authentication with email and password. But I think it's worth mentioning that it's nice to put these kinds of things into a method so that the actual logic is contained into a single location. If this logic ever has to change, I can change it here. And everywhere that in my application needs to register a user can just use this method with a unified interface. A lot of times there can be different types of fields on here. Is an admin, is this, is that, and you have to set those up manually. But if you do it in a method and you name it something like register admin, register normal user, whatever, then it can be, you can isolate that logic into a single location. Now, on to the first feature where speakers are able to submit their talks. So, in this case, I actually have a speaker model and a talk model, and these are isolated into their own namespace. The speaker model does have a reference to the user ID. So it knows about the user authentication, but user authentication doesn't know about speaker, and this is a recurring theme. Anybody who uses my application that I need to authenticate, the type of model that represents them, in this case speaker, will know which identity it's attached to. So the way that looks is, this is just a controller. I'll just go through it really quick. This is my welcome screen where I have a, hey, you want to come to my conference? You can log in, you can register, you can do whatever you want to from this beautiful page. I didn't design one, it's just text. And simple login. It's normal Laravel stuff. But the registration, it's a little different because I'm going to do form validation first, boring. And then I'm going to create the actual authentication token. And then I'm going to use that authentication token to create a speaker. So it's possible that in my system, you can be a speaker and an organizer or any number of different types of user. And I can use the same authentication token for any of those models. But each role, like speaker, admin, organizer, can have its own model with its own behavior. I find that one big source of problems with this kind of modeling is that a user will just be a magnet for everything having to do with that individual. It might be text fields, it might be various properties, permission types. You can even have like a user type field that just has an enum like admin or speaker. The problem is these things don't actually scale well, and sometimes they can even start to contradict one another. So it's impossible to keep the model into a consistent state with your business rules. By having a unique model for each of these roles and represent it on its own merit, we end up with very small classes that have behavior very specific to its role. And so in this case, I'm passing in the user authentication token, and I'm actually type hinting for an object of type user authentication to make sure that I get a model in there. So I believe the speaker, yeah, here's the speaker model. I call this table talk submission speakers. Why? Because again, this feature is talk submission. It's a speaker being able to submit their talk. And if I want to segment off and bound off this feature from other features, then I'm going to need to be able to have another speakers table if I want to, have another talk table if I want to. So this is kind of like just namespacing for MySQL. And then my registration method, I take that user authentication and some arbitrary data that I decide I would collect, and I just spit it into a model and spit it back. So you can see user ID is equal to the user ID. And then whenever I need that speaker model, I can just pass in the authenticated user. Down here, the for user method. I pass in whichever user is authenticated, and I get back the correct speaker model. And then that entire feature is then dependent upon the speaker model, and only the speaker model has information about which user that speaker is. Now, if I want to submit a talk, I just made a middleware called isRegisteredSpeaker. And it's just like a normal applications that are heavily event driven. I take things into a really dark place, and I'm happy to talk about that later if you want to find me during lunch or whatever. But if I want to view a talk for security reasons, I pass in the speaker and the talk ID so that they only can see their own stuff. And that's really it. Now, this is when I get out of just one feature, because that feature alone is similar enough to a typical a model. But now I add a second feature, and it's going to have to relate to the first. And the way I'm going to do this is I'm going to have a talks table. It's not the same table as the speaker talks table from the previous feature. I have an organizer table, which is similar to the speaker table from the previous feature in that it refers back to a user ID. So it's entirely possible to have a user that is both a speaker and an organizer and has access to all of those things. And I don't have to do anything complicated with role management or anything to handle that. So how do I know who an organizer is? I just decided that somebody's an organizer. I didn't build a user administration tool or anything. So if you look at the source code that I have on GitHub, there's just a little command where you can just trigger yourself into an organizer. Where do I get the talks though? And this is the interesting thing about this. How do I know what talks I can look at to approve if I have these boundaries and I can't communicate over them? So here's the talk submission feature. Here's the talk approval feature. I can't cross this boundary. If I do, then what I've done is I've removed the chance to modify one of them in isolation. Let's see, what time is it? Sorry. Okay, I think I'm doing okay. Can you let me know at 10 minutes, Pod? Okay. So these features look incredibly similar. And this happens to me a lot, actually, because when I end up writing systems, I end up with a bunch of very small features that are very simple, only do exactly what the feature is intended to do, and they don't relate into other things, and therefore I can modify any of them freely. But how do I get the talk from the submission into the approval? Well, this is where I get back to events and how events are magical, because it's just a plain class in Laravel. It's just a simple class that I can point at. So I'm going to raise the event, talk was submitted. When someone submits a talk, I say this talk was submitted. Then inside the feature, the bounded context of the feature, talk approval, then I have a listener called register submitted talk. So here's my talk was submitted event. It's just a constructor with a bunch of stuff. It assigns the stuff to fields and provides getter functions. I like this because, well, once the object's created, you can't modify any of the fields, and so that's always a good thing. I don't like when things break. Then the listener, it says, hey, look, yeah, okay, this is where the talk's actually submitted, in the submit method. So first I create the model, and I use the speaker ID and the title and description, notes, etc. Then here's where I raise the actual event. So when that model is saved, the event's raised. And this is that talk model knowing about the event. So if the event interface does change, then you do have to change the listeners. But at that point, that's it. There's a very specific layer that's sliced out of the application architecture so that if something changes in the protocol, it can be managed at that layer. And here's the listener, and this is the entire listener. It just takes that event and registers that submitted talk in the new feature. So now we go from the talk was submitted to registering the submitted talk, and now I have the talk in that new feature. And so as the organizer, I can see a list of all the submitted talks. I can go and click approve. Now, when I do, of course, it's going to raise a new event. Talk was approved. And when that talk's approved, I want to be able to schedule the talk, and I just went ahead and created a listener called auto schedule the approved talk. And that just fits it into the next spot in the schedule. If I wanted to build out that feature more, then I could have schedule ordering, time management, etc. But my goal really is to talk about the separation, the isolation, reducing the scope of these models, and how you can communicate over boundaries, and hopefully have enough time for questions, which I really hope someone has questions, because I think this is an important subject. Should you use these techniques? You know, I have no idea what you should do, but if any of this sounds good, then maybe you already are feeling my pain and the reason I kind of ended up going down these roads. What I do is, if I have this problem that I can't even refactor a system because I'm going to create bugs, I don't want to have bugs like at all. I want to have like maybe 1 or 2 bugs that are maybe caught in testing, but do I need to have like these deep integration tests, hundreds of them for my application? I mean, you kind of do. If you have this huge sprawling interrelated node structure, graph basically, then it's entirely possible to break something in a feature that you're not even considering. And so what I think is a good idea is to have a hobby project and just take this idea and say, I'm just going to do the most ridiculous thing, and I'm going to actually separate this stuff and keep it isolated perfectly forever and see how it works out. And I think that when it comes to like these architectural ideas, a lot of times there's a lot of pushback, because I want to be fast. I want to stay fast. For example, test-driven development. I think a lot of people push back on that because it takes time to do. Well, what I did with TDD is I spent about a year doing katas, just forcing myself to do it, in my spare time. But I'm so fast with it now. I can make a test really fast. I can design software really fast that actually has different properties than the software I would design otherwise. Okay. Yeah, that makes sense. I think that unless we are willing to just say, throw away what we think we know about how development's done fast and well, and actually invest in experiments that are philosophical, conceptual in nature, pursue like more of the academic truths, like the truth about the exposure of the large graph versus the exposure size of the smaller graph. It really embrace these ideas and create experiments that can train us how to think about them, and it will be slow, but then we get fast, and it to the point where the way I wrote software 5 years ago, and like I've been doing this for 20 years, the way I did 5 years ago is like another person. It's like another life. I can't even imagine going back to that. I don't deliver bugs like I used to. I mean, I could just kind of go on this, but so I'll keep it short. But there's a huge difference in rapid application development and a more careful, deliberate approach in the ultimate outcome. And what's right for you isn't for me to say, or your project. But experimenting will give you tools, not just with this idea, with all the ideas. Experimenting with all the ideas will give you the tools to make the decisions. We have this idea of the right tool for the job, but I think it's like inherently a lie. I don't believe that we use the right tool for the job. I believe that we use the tool that we know. And so unless we're actively and deliberately studying, exploring viewpoints that we don't already have, then how can we choose the right tool? Now, that's the end of the talk, and I hope we have questions, because I really would like to talk about this more. This is the URL for the source code for the working application. It has a Vagrant virtual machine, so you should be able to fire it up and get the application running in moments and interact with it directly, or just look at the source code, that's fine. Yeah.